You know that feeling, right? Staring at a wall of raw data, and you just know there's a story in there somewhere, but you have no idea how to find it. Well, today, we're going to break down that exact process, how to turn total data chaos into crystal clear insights.
So there it is, the spreadsheet. It's just sitting there, a giant grid of numbers and text staring you in the face. You feel like it's trying to tell you something really important, but all you see are columns and rows. It's a classic problem. Where do you even start?
Well, the answer is a process called exploratory data analysis, or EDA for short. Honestly, the best way to think about it is as the first conversation you have with your data. You're just getting to know it, seeing what it's all about, before you jump to any big conclusions.
Okay, let's nail this down. EDA is not about finding the final answer right away. Instead, picture yourself as a detective arriving at a crime scene. You're not pointing fingers yet. You're just dusting for fingerprints, bagging evidence, and getting a feel for what happened here.
And just like any good detective, you start small. Before you start connecting threads on an evidence board, you look at each piece of evidence by itself. In the world of data, that means looking at one single variable at a time.
To do that, we start with some really simple stats. We basically ask two questions. First, what's a typical value? That's your central tendency, things like the average. And second, how spread out is everything? That's dispersion, like the range. Super simple, but super important.
But here's the thing, numbers alone don't give you the full picture. This is where visuals become absolutely critical. You can instantly see the shape of your data. Is it a nice balanced bell curve? Or is it skewed with a long tail? That shape can tell you things that a simple average would totally miss.
All right, so once we've inspected each clue individually, it's time for the really fun part. This is where we start connecting the dots. This is where the plot thickens and the story really begins to take shape.
Now we start asking those bigger, detective-style questions. Okay, do these two variables always move together? Wait a minute, are these two clues just telling me the same thing? And the big one, which of these variables actually seems to have an impact on the outcome I'm trying to solve for?
To answer all of those questions, you need the right tools for the job. So let's open up the toolkit. We're going to do a quick tour of 5 essential charts that every data detective absolutely has to have.
Let's start with the absolute most common question you'll face. You've got 2 sets of numbers, and you just want to know, are they related? You know, like, does more study time actually lead to higher quiz scores?
Boom! The answer is a scatter plot. It's so simple. Each dot here is a person. As you move to the right, showing more study hours, you can see the dots tend to go up, showing higher scores. That upward trend tells you everything. If it looks like a tight line, you've found something strong. If it looks like a random shotgun blast, well, there's probably no connection there. Okay, tool number 2. What if your data isn't just a snapshot in time? What if it's a moving picture, changing day by day, or even minute by minute? How do you see the pattern in that? For that, you use a run chart. I love this one. Think of it like an EKG, the heartbeat monitor for your data. It plots a value over time so you can instantly spot trends, weird repeating cycles, or any sudden shifts. It's fantastic. All right, time to level up. Looking at 2 things is great, but what if you suspect a third factor is involved? How do you possibly show 3 variables on a flat chart without making a complete mess?
You use a bubble chart, and this is so clever. Look, it's basically just a scatter plot. In this case, revenue versus profit. But here's the twist. The size of each bubble tells you about a third variable, like how many employees a company has. All of a sudden, you can see if bigger companies are actually more profitable. It's genius.
Okay, now we're getting into the really tricky stuff. In the real world, it's rarely just one thing causing another. It's usually a whole combination of factors. So, how on earth do you visualize that complexity? You use what's called a multivariate chart. Now, I know this one looks a little intimidating at first, but the idea behind it is incredibly powerful. It's showing how different factors like temperature and humidity work together to influence something like energy use. It helps you find the complex recipe for what's happening. All right, final tool in the rapid tour, and this one is a game changer. What if you have, say, 10 or 20 variables? You can't make 100 different scatter plots. You need a way to get a bird's eye view of all the relationships all at once.
And that is where the heat map comes in. This thing is just brilliant. It uses color to show you how strong the relationship is between every single pair of variables you have. Bright colors mean a strong connection, dark colors mean a weak one. In one single glance, you get an X-ray of your entire data set.
Now, a visual like a heat map is amazing for spotting leads. But our detective story isn't over. The pictures point you in the right direction, but they are not the final proof. You still have to confirm your hunches. See, behind that beautiful, colorful heat map, there's an engine making it run. And that engine is the correlation matrix. It's not a graphic, it's just a table of numbers, but it's what quantifies the strength of every relationship. The visual gives you the aha moment. The matrix gives you the hard number.
And that's really the key workflow here. You use the visuals to explore and form a hypothesis, a hunch. Then you bring in the heavy-duty statistical tools, the numbers, to prove whether that pattern you spotted is a real, significant finding or if it was just a random coincidence.
Which brings us right back to the real goal of this whole process. It's not about being in a rush to find one single final answer.
So let's sum it up. Exploratory data analysis is all about, well, exploration. It's where you find your mistakes, spot the weird outliers, and start turning that messy spreadsheet into actual insights. Because it's real power. It isn't finding all the answers. It's about getting you to ask much, much smarter questions.
So the next time you're looking at a data set, just remember, it's talking to you. It's whispering clues and trying to show you something you didn't know. The only question left is, are you listening?